Buckle up, everyone, because today we are diving deep, and I mean deep, into the world of Jupiter. Specifically, those icy moons with Gisè's JUICE mission. And let me tell you, the excerpts you sent over from the science of JUICE from Zero to Jupiter, it sounds like we're dealing with a real head-scratcher here.
Oh, a head-scratcher with some seriously big implications, if you're asking me. We're on the hunt for life outside of Earth, and JUICE, well, it might just hold the key.
No kidding. Now, Jupiter's had its fair share of visitors, right? 9 spacecraft so far, if I'm not mistaken.
Yeah.
So what makes this mission, this JUICE mission, the first European mission to Jupiter, such a big deal? What sets it apart?
Well, for starters, it's a European mission leading the charge to the largest planet in our solar system. That's a big deal, wouldn't you say? It really shows how far Europe's space program has come. And JUICE, oh, it's a technological marvel. Cutting-edge tech, 10 state-of-the-art instruments, plus a shining example of international collaboration. But the real star of the show, Jupiter's icy moons, those mysterious worlds that just might harbor life beneath their frozen exteriors.
Okay, you had me at icy moons and potential for life. But before we get ahead of ourselves, how did this whole ambitious mission get off the ground? I heard a little rumor about a pub being involved.
You heard right. Our source spills the tea seems the JUICE acronym, which, by the way, stands for J Jupiter Icy Moons Explorer, was born in a pub, over gin and tonics, no less.
Now that's dedication for ya. So, let me get this straight. Some of the most brilliant minds in space exploration are just chilling at a pub, tossing around ideas for a mission to Jupiter.
Well, that's one way to put it. But in all seriousness, it really highlights the human element behind these incredible missions, you know? Real people, driven by an insatiable thirst for discovery. And sometimes, just sometimes, the most groundbreaking ideas are sparked in the most unexpected of places.
Love it. Proof that even rocket science starts with people, curiosity, and maybe a gin and tonic or two for inspiration. But let's back up a sec. This pub conversation, it eventually morphed into part of ESA's Big Picture Cosmic Vision program, all right?
Spot on. You see, JUICE embodies ESA's grand ambition to tackle the really big questions, the ones that have kept humanity guessing for ages. How did our solar system come to be, and are we perhaps not alone in this vast universe?
Right. So it wasn't just about Jupiter and its moons. It was about cracking the code of our cosmic origins and searching for life beyond our own little planet. All that over a few drinks. Impressive.
Precisely. And that brings us back to those fascinating icy moons, Europa, Ganymede, and Callisto. Each one is like something straight out of science fiction, potentially harboring massive oceans of liquid water beneath their icy shells.
Okay, so we've got these icy moons as the prime suspects in the case of is there life beyond Earth. Why are they so special? I mean, why not just focus all the attention on Jupiter itself?
Well, Jupiter is a tough nut to crack. It's a gas giant, a colossal ball of swirling gas. The environment. Let's just say it's not exactly welcoming. Life as we know it would have a hard time surviving in Jupiter's atmosphere. But its moons. Now, those are a different story altogether. They hold the magic ingredient, the lifeblood as we know it, liquid water.
And not just a drop in the bucket, right? We're talking about potentially more water than all the oceans on Earth combined.
Now you're getting it. And get this, that water, it's thought to be in liquid form, tucked away beneath those icy shells. And the secret to keeping it liquid, likely the heat generated by tidal forces from Jupiter and the gravitational dance between the moons themselves.
Hold on, tidal forces. You're going to have to break that one down for me. How does Jupiter's gravity create heat on a moon that's millions of miles away?
All right, picture this. You keep stretching and releasing a rubber band. It heats up, right? Now imagine Jupiter's gravity as this massive hand constantly stretching and compressing a moon like Europa or Ganymede.
Okay, I'm starting to see it. So these moons are like giant cosmic stress balls being squeezed by Jupiter, creating friction and generating enough heat to keep those subsurface oceans nice and liquid. That's wild.
Wild is an understatement. And you know what's even wilder? Wherever we find liquid water, a source of energy, and the right chemical ingredients, there's a chance, however slim, that life as we know it could exist.
Okay, so we've got liquid water, a potential energy source, and who knows what kind of cosmic soup brewing beneath those icy shells. It's like these moons are giant cosmic petri dishes just begging to be explored. But hold on a sec, getting Jupiter, that's no walk in the park, right?
You're telling me we're talking about a journey of over 1 billion kilometers. That takes some serious engineering, my friend. JUICE, it's going to be cruising through the cosmos for over 7 years, navigating all the dangers of deep space, just to get to Jupiter.
7 years, that's like, what, almost twice as long as it took us to get the first images back from that black hole. It really puts the size of our solar system and the patience of these scientists into perspective.
Oh, absolutely. But here's the thing. It's not just about building a tough-as-nails spacecraft that can survive the trip. GYC has to be smart. It has to use the gravity of other planets to slingshot itself towards Jupiter, picking up speed along the way. It's a cosmic ballet, a delicate dance of celestial mechanics.
You're talking about those gravity assists, right?
Hey.
Always heard about those, but never fully grasped how they work. It's like free fuel, but from space.
Yeah. Exactly. Ju is going to use the gravity of Earth, Venus, even the Moon to slingshot itself toward Jupiter. It's all about saving fuel, and let me tell you, in space, every gram counts.
Speaking of fuel efficiency, I read about this wild maneuver they're doing, the LEGA, that's Lunar Earth Gravity Assist, right? The first of its kind. What's the deal with that?
Oh, yeah. LEGA, that's a game changer. Just shows you the ingenuity of this mission. Picture this. GYC is going to swing by the moon, use its gravity for a little speed boost. Then it's going to loop back around Earth and steal even more momentum from our planet's gravity, like a cosmic bank shot.
So GYC is zipping around the solar system playing gravitational billiards with planets and moons. Okay, I'm starting to get a headache just thinking about all those calculations. Why not just aim GYC at Jupiter and hit the gas?
Well, think of it this way. Gravity assists, they're like taking the scenic route on a road trip. Sure, you could take the highway and burn through all your gas, or you could cruise along those back roads, take in the scenery, and save some fuel for the fun stuff later.
Makes sense. Every bit of fuel saved means more science once GYC gets to Jupiter. Speaking of fuel, our source mentioned this super important burn that went down back in November 23. Seems like they used up a good chunk of GYC's propellant, right?
Yeah, that was a big one. I think it was Julia Schwartz, a flight dynamics engineer over at ESA, who described it best. She said that burn used up something like 10% of the fuel GIC launched with. Sounds like a lot, but it was absolutely crucial for getting GIC on the right path for that 7-year voyage.
Talk about pressure. One tiny miscalculation, and Juicy could have ended up, who knows where. Really shows you the insane level of precision involved in these missions.
You got that right. Speaking of incredible feats, let's talk about the spacecraft itself. Remember those 10 scientific instruments we mentioned earlier? Those babies are going to be working overtime once JUICE reaches Jupiter.
10 instruments. That's like a whole space laboratory crammed into one spacecraft. I gotta be honest, sometimes all the technical stuff makes my head spin. Where do we even start?
Don't worry, I'm here to walk you through it. Let's start with Janus, the camera system. You know, the one that's going to beam back those jaw-dropping images of Jupiter and its moons. Everyone loves a good space picture, am I right?
Oh, absolutely. But Janus is more than just a fancy camera, right?
Yeah.
It's got to be packing some serious heat if it's going to capture anything from 1 billion kilometers away.
Oh, Janus is packing heat, all right. We're talking high-resolution, state-of-the-art imaging. It can spot a coffee table on the surface of Ganymede from space. And it's not just about pretty pictures, although trust me, there will be plenty of those. Janus is going to help scientists map those moons in stunning detail, study their geology, search for clues about how they formed and evolved.
So it's like having a super-powered magnifying glass in space, giving us a close-up view of these icy worlds. What else you got? Hit me with another one of the Juicy's cool gadgets.
Okay, how about this? Imagine being able to figure out what something's made of without even touching it. That's what MAGIS does. That's the Moon's and Jupiter Imaging Spectrometer.
Wait, seriously? That sounds like something straight out of Star Trek. How does it work? You've got a magical space sensor.
It's all about light. MAGIS analyzes the light bouncing off Jupiter and its moons. Different elements and compounds, they absorb and reflect light in unique ways. So by studying the spectrum of that light, MAGIS can tell us what those worlds are made of.
Okay, I'm mind blown. So Janus is our eyes in space.
Yeah.
AGS is breaking down the chemical makeup.
Yeah.
What about the atmosphere of those moons? Don't tell me JOES has something for that too.
Oh, you better believe it. We're talking about UVS, the UV imaging spectrograph. It's like a superpowered telescope, but it sees in ultraviolet light.
Okay.
You know, the stuff that's invisible to our human eyes.
Right, like those black lights that make everything glow in the dark, but for space. What's going to see with this ultraviolet vision?
UVS is going to be studying those super thin atmospheres around the icy moons, looking for things like water vapor. That's going to tell us a lot about what's happening beneath the surface in those hidden oceans.
This is incredible. Each instrument is like a piece of a puzzle, right? And when you put it all together, you start to get a clearer picture of Jupiter and its moons. But with 10 instruments, things must get pretty crowded on board JUICE. How do they even fit all that stuff in there?
That, my friend, is the magic of engineering. They've designed Ju-E to perfectly accommodate all of its scientific gear. And here's a fun fact: that UVS instrument I was just talking about, it's actually got some heritage from previous missions, like Rosetta and New Horizons. They took the best parts of those instruments and adapted them for JUSIS.
So it's not just about building shiny new tech, it's about using what we've learned from past missions and making it even better. But with all this talk about the moons, does JIEC have anything dedicated to studying Jupiter itself?
You know what they say, can't have a Jupiter mission without studying the big guy himself? Remember that crazy swirling atmosphere we were talking about? Well, JIE has an instrument called SWI, the sub-millimeter wave instrument, and its sole purpose is to study it.
Oh yeah, Jupiter. It's basically just a giant ball of gas with those insane storms raging all the time. What can SWI tell us about that chaotic mess?
Well, SWI is like a weather station on steroids. It measures temperature, composition, the whole 9 yards.
Yeah.
Gives us real-time data on what's happening down there. And get this, SWI is the first ever real-time spectrometer to be flown in deep space.
Whoa, that's a pretty big deal. So we've got visuals, chemical analysis, atmospheric readings, even real-time weather reports from Jupiter. Is there anything JIEC can't do?
Well, it can't defy the laws of physics, at least not yet. But it's got one more trick up its sleeve. Remember those subsurface oceans we keep coming back to? Well, it's time to dive below the surface, and for that we have RIME.
RIME. Okay, I'm going to bite. So what's that stand for?
Radar for Icy Moon Exploration. And let me tell you, this is where things get really interesting. Imagine being able to see right through those icy shells to map the subsurface of these moons. That's what RIME brings to the table.
You're kidding me. It's like having X-ray vision, but for icy moons. How deep can it see? Can it see all the way down to those oceans?
RIME can penetrate the ice up to 9 kilometers deep. We're talking about mapping different layers of ice, seeing the rock below, finding evidence of where liquid water might exist or used to exist. It's like digging into the history of these moons.
This is unbelievable. It's like peeling back the layers of a cosmic onion.
Yeah.
But hold on, with all the interference and noise from Jupiter, how can RIME get a clear signal? Isn't Jupiter like a giant radio wave emitter or something?
That's a great question, and it was one of the biggest challenges for the RIME team. They had to develop some seriously sophisticated algorithms to filter out all that noise from Jupiter. It really is a testament to their hard work and ingenuity.
It's mind-boggling what these scientists and engineers can accomplish.
It really is. But guess what? We're only halfway through JUIC's toolkit. Still got more instruments to uncover.
Wait, there's more. You're going to have to give me a second to catch my breath. My brain can only handle so much scientific awesomeness in one go.
I think you can handle it. Besides, wouldn't want to leave out any of these incredible instruments, right? Each one plays a crucial role in unraveling the mystery of Jupiter's icy moons. Ready for more?
Hit me with it. What's the next piece of this cosmic puzzle? All right, lay it on me. What's the next piece of JUIC's scientific arsenal? We've got cameras, spectrometers, a radar that sees through ice. What else could they possibly need?
Well, remember how we talked about those tidal forces, the ones stretching and squeezing those moons?
Yeah, like Jupiter's playing cosmic squash with them.
Exactly. We've got an instrument designed to measure that. GLA, the Ganymede laser altimeter.
A laser altimeter. Sounds fancy.
Oh, it is. It's going to create a super detailed map of the moon's surfaces. But here's the really cool part. GALA can pick up on tiny changes in their shape caused by Jupiter's gravity.
So, if a moon is being stretched out of shape, GALA will see it.
You got it. It's like taking their pulse, revealing what's going on beneath all that ice. Yeah. We'll learn so much about those hidden oceans.
Incredible. So, we're seeing the surface, peering into the atmosphere, even looking deep down inside. Is there anything GALA can't do?
Let's not get ahead of ourselves. It can't defy the laws of physics.
Right, of course.
But it does have one more trick up its sleeve. Remember how Ganymede has its own magnetic field?
Yeah, the only moon in our solar system to have one, right? Pretty impressive.
Totally. So JI has an instrument called JMAG, which is going to measure the strength and orientation of that magnetic field with incredible accuracy.
What will that tell us?
Think of it like a compass, but instead of just pointing north, it tells you the entire history of the magnetic field around you. We're talking about unlocking secrets about Ganymede's internal structure and how it interacts with Jupiter's own powerful magnetic field.
Okay, color me impressed. It seems like GIC is ready for just about anything. But wait, didn't you say there was one more instrument?
Yes. But this one isn't actually on the spacecraft itself.
Whoa, what do you mean? Like a remote control?
Even cooler. It's called PRIDE, the Planetary Radio Interferometer and Doppler Experiment. And get this, it uses radio telescopes right here on Earth to track GIC's position.
So it's like a giant space GPS.
Exactly. By analyzing the radio signals from GeoCI, scientists can get super precise measurements, and that helps us understand things like Jupiter's gravitational field, even refine our understanding of the moon's orbits.
This is mind-blowing. This mission really does feel like the culmination of so much planning, collaboration, and pure scientific ingenuity.
Couldn't agree more. Scientists and engineers from around the world came together for this, pushing the boundaries of what we thought was possible. It's a real testament to what humanity can achieve when we set our minds to something.
Absolutely. As we wrap up our deep dive into GeoCEA, it really hits you just how ambitious this mission is. It's bigger than just one planet or a few moons. This is about tackling the big questions. Where did we come from? Are we alone?
You hit the nail on the head. G is searching for clues to the story of our solar system and looking for hints that life might exist beyond Earth. The data it collects, it'll keep scientists busy for decades.
Amazing. A great reminder that space exploration, it's a journey, not a destination, right?
Yeah.
And GGE, well, that's one incredible chapter in that journey. But before we go, got a thought-provoking question for our listeners, something to chew on.
How about this? What if GUC discovers that those icy moons, they're not just habitable, but they're part of this vast network of watery worlds? What if life, as we know it, isn't confined to planets with surface oceans, but could exist in these hidden subsurface realms? It'd change everything, wouldn't it?
Now that's a question to keep you up at night. It really makes you realize how much is still out there waiting to be discovered. And JUICE is just the beginning. Well, folks, thanks for joining us on this epic deep dive into the JUIC mission. Until next time, keep looking up,